Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
very much interested in the digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enroll in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He's not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, knowledge, and in the exam. So to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently I was searching for digital marketing courses online in Google, and I came across XLR and I attended a digital marketing course which was for 15 days. My mentor for attending these classes. So he is very informative and in the course end there is a exam which I taught. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online because it's teaching form for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the
Good evening, all. I hope you are doing well. Student, I request please inform your friends to join the session. As we have a less participants, so I request please inform your friends to join the session as soon as possible. So we will start for the day. Good evening, sir. Mantal sir, is I'm audible?
Yes, ma'am, you're audible. Good evening, everyone.
Yeah.
Am I audible?
Yes, sir, you are audible. You can start
Okay.
for the day.
All right. Just give me a second. Okay, good evening, everyone. So, in the previous session, we studied on how exactly transaction work. Okay. And I think there's a student who had a doubt. I was not able to take that because I was never no, I was not able to understand the question. But I guess the question was related to that script SIG and script republic key. Okay, so I'll do a quick revision. I'll do a quick revision on what exactly it was. Okay. Let me just share my screen. So that we have seen that this is the reason everything is peer to peer, because if we see a normal communication that's happening in the internet, it's peer to peer, but it involves cryptography. Okay, recipient's public key to encrypt the message so that you are able to send them message. Okay, so instead of messages we have a value here, it's a digital entry. So we are just applying a private key to show the network that yes, this coin, this value, this digital entry is right now belong to me and I'm willing it to send it to someone else. Okay. So if you remember, I'll take the example again. We had Alice. Okay. Suppose Alice has 5 Bitcoin. So this is just an entry. Okay. Now we see there were two things, two scripts. First script was known as script sig. Okay. Other was known as script public key. Okay. So here we have taken input. Now, as soon as Alice is intending to send this 5 Bitcoin to, let's say, Bob, we have Bob 2 here. Okay. Now, she will come across these two scripts which are placed in stack. That means first it has to be look upon, and then after scripts public key have to look upon. Okay, so they are placed in stack. So this is 1 and this is 2. So as I told you, this scripts is just the private key of Alice. Private key of Alice. So that the transaction, the message is unlocked again. Because if you guys remember, a message encrypted using someone's public key can only be decrypted, can only be unlocked using their own private key. So first we have to unlock it, then we can able to lock it again. Okay, so first we have to unlock it. So private key will be helpful for unlocking it. So private key for of Alice, and this is also known as unlocking script. Unlocking script. On the other hand, once it is unlocked, then Alice can relock it. Okay, relock it with Bob's public key. Bob's public key. And what is this public key known as? Address. Okay. Now once all these two scripts are met, these 5 Bitcoin will be transferred to Bob with Bob's public key as encryption. Now this process will be the same again. Suppose Bob wants to send it to someone else. Then Bob has to unlock it first. So how will he unlock? By applying his private key. And then he relock it with recipient's public key. Okay, so this was the entire structure. Okay, so I guess you must be receive the document on LMS. Okay. And yeah, I'll write it here. Output. So this 5 Bitcoin, which was previously as UTXO, will not be considered as UTXO once sent to Bob. But now this 5 Bitcoin will be considered as UTXO of Bob, unspent transaction output. Unspent transaction output. Okay, so that was the thing. That's the thing. All right, on how exactly transactions happen in Bitcoin or any other cryptocurrency. Okay, now why this UTXO is also important to stop double spending attack. Double spending attack. Okay, a new term, a double spending attack. So double spending attack, it's really easy to imagine. Suppose I have a 500 rupee note. Okay, I have a 500 rupee note. So what I'm doing is I'm spending this 500 rupee note to a person A. Simultaneously, I was able to pay that 500 rupee note to person B. I know to imagine it's really difficult, but just imagine it. I made a photocopy of that 500 rupee note and I was able to send, or I was able to pay that 500 rupee note to two different people. Okay, so that is known as double spending attack. Because see, in the physical world, when we have physical cash, it's really difficult because it's a unique note. But when we talk about computers, when we talk about digital data, anyone can copy it. Anyone can copy anything. I suppose I created a Word file and I've written it there 5 Bitcoin. So I can create multiple copies of it. Similarly, there could be there could be multiple digital entries as well. Okay, so Bitcoin solves that problem. Not Bitcoin, blockchain solves that problem of double spending. Okay, it solves the problem of double spending. So how it's done? How it's done? I'll show you again. If you didn't take the screenshot of it, just take it. I'm giving you 5 seconds, then I'll rub it. And this is known as locking script. I'll write it here. Locking. Okay. Take screenshot. All right. Now, inside blockchain, inside Bitcoin, there's an array that stores the output transactions that happen inside the blockchain or Bitcoin. Okay, suppose this is Alice. Okay, Alice is sending uh sending 5 Bitcoin to, let's say, to Bob. So this is the entire data, okay, which is just a transaction because it stores the private key. So sorry, it stores the public key of Bob. So this is the entire data. Now this entire thing will be given to Bob. Okay, will be given to Bob. Now what happen is there's a array. There's an array that maintains all the output, all the UTXOs that happen inside a Bitcoin. So they will store this thing, 5 BTC to Bob. 5 BTC to Bob. Okay. Now what will happen is, suppose Bob tried to give another person, suppose this is Oscar. Okay, there will be a time, okay, there will be a time when Bob is able to give Oscar first. Okay, because there will be a fraction of second. Okay, that differs. All right. Suppose again Bob send this 5 Bitcoin to Bob. Okay, Bitcoin to, I mean, this entire data to Bob, to Oscar. Okay, so now this data will be stored here. What should I write it? I'll write it at, okay, no problem. 5 BTC to Bob to Oscar. Okay, now suppose if that person tried to give this data to, let's say, another person, let's say this is Eve. Okay, so what will happen? Eve is able to check, if this transaction is never happened before or not. Okay, so it's coded inside, it's coded everything, so it will check this 5 Bitcoin to Bob doesn't exist before or not. Okay, so once a transaction checks inside the array, it will check this transaction already belongs to someone, so it will decline it. Okay, it's just a normal code. You just have to check in the array if the data is present or not. If it's present, that means you are not able to send it to someone else. So this is how Bitcoin solves this problem, because this data is with everyone. Like I told you, this data is with everyone. Every peer stores this information. Every transaction is broadcasted to everyone. Okay, so this is how they see it. But now criminals are really smart. Okay, they can, what do I say? They can temper the routers. Okay, they can temper the routers. They can delay in the block propagation. Okay, so this is the way they can do it. Okay, that's something which is uh, really technical. Okay, only hackers or who are into, okay, hacking, who are perfect into this, only they can do it. Okay, so double spending is prohibited in blockchain. All right. So that's a quick revision of what we studied in the last session. Okay. Now let me just share my book. I guess we completed with case study of Bitcoin. I told you what Bitcoin halving is. Okay. Okay. Now we have to discuss what different types of transactions happen in Bitcoin. Okay. So let me just share my screen. Okay, it's whiteboard only, no? All right. Okay. Now we'll see types of transactions. Types of transactions in Bitcoin. The old one, the standard one, is known as P2PKH. P2PKH. And you know what's the full form of it? It's pay to public key hash. This is the full form of it. P2PKH or pay to public key hash. Now I'll ask you guys, what do you understand by public key hash? What is public key hash? Anyone? What is public key hash? What do you understand by public key hash? What is a public key hash? What is PK? Anilish, what is PK? Full form PK? Okay, public key. See, I told you, public key is a very large, okay, it's really large. And it takes a lot of space. So what hashing can do, hashing produces a fixed length output. Okay, so that's what a public key is. Public key is a key which is no, Neha. Yeah, we all know what a public key is, but what do you understand by public key hash? Yes, manageable value. See, public key hash is just an address. I told you address. What is address? Address is just a hash of your public key, right? Maybe paying or to get hash of public key. No hash. Okay. Public key hash means the address. Public key hash means address. If you create a public key using, let's say, elliptic curve cryptography and you hash it twice, okay, you will get a thing which is known as address. So address is just a public key. I told you. So it's exactly not a public key, but it's a hash of public key. Okay, so it's not directly visible to everyone. Okay, so we hash it. So pay to address, pay to public key hash means pay to address, normal transaction. If I want to send someone 5 Bitcoin, I'll need their public key, I need their address to send the transaction. So this is the most common, not most common, but this was the first transaction type introduced in Bitcoin, P2PKH. It's now really difficult to find out such nodes or such people or such users who are using this. It's the old one. Okay, it's the old transaction type. P2PKH or pay to public key hash or address. All right. Okay. Second is known as multi-signature. What do you understand by multi-signature? And what importance does it play? What importance does this multi-signature plays? Anyone? If this is that unique key, why such big public key is needed? If this is that unique, no, then it's not that unique key. Unique key is the private key that belongs to the user. Public key is it's available with everyone, right? Digital signature plus public key. Uh, No, not exactly. But it's related to digital signature only. What is the question? Yeah, question is, what do you understand by multi-signature? When you talk about multi-signature, yes, multi-signature is a second verification. It's, we can say, a two-factor authentication or multi-factor authentication. Exactly, more than two people signing it. And why it's useful, guys? What's the importance of it? Can anybody explain me using an example? Why it's really important? Not able to crack. Okay, that's good. WhatsApp end-to-end privacy. Yeah, WhatsApp end-to-end privacy is also maintained using cryptography. More safely. Yes, Lesh. The answer is more safely. Suppose guys, you are a single person who do a transaction. You want to send, let's say, 100 Bitcoin to someone. But what if someone stole your private key? What will happen? They can easily, they can easily transfer your crypto to anyone or to themselves also. Okay, but now suppose to gain access to a crypto, you need at least two more than two private keys to do a transaction. Suppose Alice and Bob are, are parties to each other. Okay, they have decided that if we want to do a transaction, if we want to send a transaction, both of our private key is required. Both of our private key is required. That means they cannot do these transactions once both private keys is not required. Okay, so that's what a multi-signature concept is. Okay, if you see it conventionally, in a company, if there's a document, if there is an agreement, it is not signed by a single party. It is signed by various authorities. Okay, so that it's really difficult. It's really difficult for any uh, fraud to happen. Okay, so you need multiple parties to authenticate the transaction so that it's really secure. So that's what multi-signature is. Okay, so multi-signature, I'll also show it here. Okay, so pay to public key hash, the most common type where the recipient's address is a hashed public key. The recipient must provide a signature and public key to spend the funds. Again, the same thing. Script SIG, script public key. Multi-signature requires multiple signatures to authorize a transaction. In our previous example, Alice only applied her private key in script 6 section. But now with this multi-signature, multiple authorities, multiple bodies, multiple users are required to apply their private key. Okay. So we are removing the single point of failure here. Okay, that if somebody got the access of a single private key, they still cannot do a transaction because they need their their colleagues or their partner's private key as well. Okay, so that's what multi-signature is. Multi-signature, much secure. Okay. Now third one is known as P2SH. P2SH. Full form is pay to script hash. Pay to script hash. Now, with this P2SH, people or the users can create custom scripts. Custom script. What is a custom script? Custom script could be anything. Suppose, along with my private key, I need my fingerprint. If my fingerprint is not there, nobody can actually able to transfer my crypto. So with the private key, I need my digital signature. It's like a two-factor authentication. So P2SH is a transaction form where users can create their own custom scripts. Okay, it could be iris scan, it could be your digital finger, it could be a fingerprint scan. Okay, so it provides customizable scripts. Okay, so if I show you here, oh, sorry. I show you here, allows complex transaction scripts by specifying a script hash. Now, what do you think, guys? Can we implement this multi-signature with pay to script hash? The answer is yes. Suppose I use P2SH and I try to create a script that says that suppose there's my partner. So I said I created a customized script that says you need another private key to do a transaction. So that's also a part of P2SH. So we can say this multi-signature is also a part of P2SH only. Okay. But what happened was multi-signature came first. Okay. And then pay to script hash came later on. But then it's easy. I mean, it's easy to create multi-signature using P2SH also. Okay. So multi-signature can be counted under pay to script hash. Allows complex transaction scripts by specifying a script hash. The actual script is provided when spending the funds. All right. It could be anything. Now, if I show you blockchain explorer again, we'll try to find out. Okay, yeah, a hint for you guys. If you find any transaction, if you find any address that starts with number 3, if you find any address that starts with number 3, it belongs to P2SH or multi-signature. Okay. If you find anyone which starts with BC, this is the most common now. They are using P2, 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 P2WPKH, P2WPKH. So this is, we'll discuss later on. What does this W mean? Okay. It's just an advanced version of P2PKH. Okay. So let's just see here. Okay. I think my screen is visible. So I'll go to Bitcoin. If we open any of the latest, let's open a block that was created at 7:24, 10 minutes ago, 8 minutes ago, now 9 minutes ago. And if I show you one of the addresses, that starts, there's a one that starts with number 1 also. Then let's see what is the type. The type is C. This is P2PKH. This is the oldest one. P2PKH. If you guys can see here, P2PKH. It's the address format. Let's find out one that starts with number 3. And most of the exchanges, Coinbase, they all starts with number 3 only. Let's look at this BC one also. It's C. This is P2WPKH. This is W is known as witness. Okay, I'll explain what witness is. It was always easy to find such, where we can find a number that starts with number 3. Any big transaction. I think this is the one. No, not yet. Let me just check. It is P2PKH only, the oldest one. You guys can also see it. I want you to open this website. Just play with it. Try to find an address that starts with number 3. Yeah, this is the one. See, I found one. 3PA. So if I open it, see what you can see here. P2SH. P2SH. P2 script hash. Now, most of them belongs to most of them belongs to a exchange. Okay. So these are the formats. Okay. These are the formats or the types of transaction that you will see in Bitcoin. Okay. Now I'll give you a task. I'll also explain what this P2, P2, WPKH is, but this is a homework also. Try to find out what this thing is, what this W is, what this witness is. W means witness. Okay. It's a very interesting topic as well. Okay. So I want you to just look at it. Cool. Okay. Now coming back here. So we understood what are the primary types of Bitcoin transactions. Now case study of Ethereum. I thought I will be covering later on, but let's see what Ethereum was. Okay, so Ethereum was conceptualized in later to 2013 by a young programmer named Vitalik Buterin. The project officially started in early 2014 with the development team including Gavin Wood. This is the person who is also responsible for creating Polkadot. Okay, Joseph Lubin and others. Ethereum's initial coin offering, ICO in 2014, raised funds to support its development. And the network went live on July 30, 2015. Now, what this ICO is? There's a there's a there's an entire uh there's an entire yeah, there's an entire there's an entire topic for it, okay, which I have covered in the last. You can see it here, blockchain fundraising models. Okay, but let's go here again. Yeah, so I think we all are aware what sorry, we all are aware what IPO is, initial public offering. Okay, what is the initial public offering? Anyone? No, it's not intermediary. It's not intermediary. You can create your own scripts. Okay. What is IPO? Initial public offering. Anyone? IPO. Share units. Can you explain more, Pawan? Selling stakes to general public. Yes. Yes. So what's the difference between the normal, normal selling of stocks to general public and what's the difference between this IPO? See, IPO is the first time when a company issues their shares for the first time in the market. So when a company issues their tokens or not tokens, issues their shares for the first time in the market, this is known as IPO, initial public offering. Initial public offering, the first time. Okay. But when we talk about this kind of distribution of shares here, but we call it tokens here or the coins. In the crypto world, it is known as ICO, initial coin offering, ICO. No different. IPO, regulated market. Okay. But when we talk about crypto world, it is ICO. So when a crypto company or when a blockchain company issues their coins or tokens for the first time in the market, it is known as ICO. So this is what blockchain did. Sorry, this is what Ethereum did. Ethereum ICO in 2014. They raised funds to support its development and the network went live on July 30, 2015. So what was the purpose? Ethereum was created to expand the capabilities of blockchain technology beyond simple financial transaction, as seen with Bitcoin. I think I also discussed with you guys earlier as well that Bitcoin purpose was to be a form of currency, a unique currency, a single currency, okay, that should be used across the world with no jurisdictions. Okay, but Ethereum said we are beyond just a currency. So what they did, it aimed to provide a decentralized platform that could execute smart contracts, self-executing contracts with the terms directly written into the code. Okay, we don't need human interference. Okay. This allows developers to build decentralized applications, dApps, that run on the Ethereum blockchain, providing new possibilities for decentralized finance, tokenization, supply chain management, and more. So they aimed higher as compared to Bitcoin. Okay. Their native currency is known as Ether. Ether is the native cryptocurrency of the Ethereum network. It is used to pay for transaction fees, computational services, and serves as the primary medium of exchange within the Ethereum ecosystem. I'll repeat again. It is used to pay for transaction fees, computational services, and serves as the primary medium of exchange. If we both belongs to Ethereum network, so we can exchange it. Okay, so it is a medium of exchange inside the Ethereum ecosystem. All right. Developers use Ether to deploy smart contracts, like I told you. Okay, I'll show you guys. So this is the ID where we practice smart contracts. Okay, so I'll just tell you the overview of it. So if you guys can see here, there are accounts that are provided with 100 Ether each. They are just dummy coins for your practice. Suppose I created a very easy smart contract. Let's say Hello World. Hello World, we all know. Okay, so inside the contract, I'll create a new folder. And inside this, I'll create a file. Create hello world.sol. The language is really easy, guys. It's really easy. First thing is we have to mention, we have to give credit to the owner who has created it. So it's a open license. I think we all know what's source license are. Okay. So I'll just paste it here. So this will not show any error, but it's really compulsory open source license. You have to credit the developers who has created it. And this Pragma Solidity, we mention the version we want to use. Okay. Then we write a contract. If you are comfortable with OOPS programming language. So in OOPS we have classes, right? If you guys remember classes. Here we don't have classes inside. Instead we rename it to contract. So contract or class is the same thing. Contract hello world. Okay. So what I'll do, I'll just print a message. So I'll take string. Don't worry if you're not into coding. Okay, I'm just here to explain how exactly smart contracts are compiled. String public, I'll take private, no problem, private message, and I'll create a function set message. Now if you guys know how do we take the user input, I'll just write string memory new message public. Inside this, what I'm just doing is message equal to underscore new message. Okay, so this is what I have created. Now what I'll do, I'll compile it. So you can see here, you just can press Ctrl+S. I'm doing it. Now if you go here, suppose I want to run this smart contract using this address 05B31. Now if I deploy it, you guys can see here, it's now being reduced from 100 to 99.999999999. Okay, because some of the fees is reduced in the form of Ether. So if you want to run your smart contract, you have to pay some fees for it. It's a decentralized thing. Okay, and if you want to see the raw data is available here. I'll show you. So if you just expand it, you will see everything. See status, transaction hash, block number. Right now it's 271. When we'll try to create our own smart contract, okay, in the later classes, For you guys, it will start with number 0. Okay. Contract address, from, to, and the gas associated with it, everything is visible here. Okay. Now, what this contract address is? Contract address. If you are from finance background, or if you have studied the Companies Act of 2013 of India, you know that every company has a separate legal identity. Company is separate from its owners or from its CEO. Okay. So you must have seen various cases where they directly mention the name of the company, not the owner of the company. Suppose I'll take an example, Union of India versus Tata. So it was not against Ratan Tata, it was against the Tata company. So Tata, I mean, any company, any organization has a separate legal identity. Like we humans, everybody has a separate legal identity. Similarly, a company has its own legal identity. Similarly, when we talk about contracts, when we create a contract has a separate identity. That separate identity is known as contract address. So this contract address is different from this address. If you guys can see it here, I'll just make it big. Contract address is 0x1589, which you'll not see here. It's not visible here. But who called this smart contract, you will see from 05B3, which is this one. Okay. So you need to pay gas. Like for running a car, okay, we need fuel. Similarly, for running a smart contract, we need fuel. And this fuel comes in Ethereum, comes in the form of Ether. All right. So Ether has various responsibilities. Ether is used for transaction fees. Ether is used for a transaction between two people. Okay, as a form of medium of exchange. Okay. All right. Now coming back here, like I told you, while users pay Ether to execute transactions and use services on the network. So this is the logo, okay, of Ethereum. Working of Ethereum. Ethereum operates on a decentralized blockchain where each node in the network maintains a copy of the blockchain. The same thing. Smart contracts are executed by EVM. This is what we'll be working on. EVM, Ethereum Virtual Machine, which ensures that contract code runs as intended. The network uses a consensus mechanism to validate transactions and add new blocks to the blockchain. Same concept. Now, I told you, Ethereum started with proof of work, but now they have transitioned themselves into proof of stake. Initially, Ethereum used proof of work, but it is transitioning to proof of stake with Ethereum 2.0. Okay. Again, Bitcoin matrices. This is the old data. If you guys want to see it, just visit Blockchain Explorer. You will find the exact data, the new data. Now, transaction record keeping model. Remember of Bitcoin, it was UTXO. I also told you that for Ethereum, it is account-based system. So Ethereum uses an account-based model for transaction record keeping. I have also told you it works similar to a UPI system or a credit card system. It works similar to a credit or debit card system. Now, there are two types of accounts. Externally owned account, controlled by private keys, which I have showed you here. See, these are the externally owned account. These are the externally owned account on my left. Okay. These are externally owned account with private keys. See, this is just a simulator. So you can imagine all these addresses are an independent person, but all can be simulated by me. Okay. And second is the contract address, which we have seen it here. So this is what they're talking about. Externally owned account controlled by private keys. These account can send transactions and initiate smart contracts. On the other hand, we have contract address or contract account controlled by smart contract code. These accounts execute code when they receive transactions. Okay. Transaction and gas fees. Okay, somebody, I think Dr. Vinod said that Bitcoin's smallest unit is Satoshi, right? Similarly, Ether has a smallest unit which is known as Way, which is known as Way. I'll rub this thing. smallest unit is Wei. So 1 ether is equal to 10 to the power 18 Wei. 1 ether is equals to 10 to the power 18 Wei. And we have 1 ether is equals to, I guess, 10 to the power 15 M Wei. Then I guess 1 ether is equals to 10 to the power 12. Oh, I'm forgetting it. What was the one? G Wei. G Wei. Okay, then we have 1 ether is equals to 10 to the power 9. I'm forgetting. It's, I guess, K Wei. Okay, I'll show you their website. Wait. Ether conversion rates. So if I write 1 here, so you guys can see it's 18. Okay, or GWay means 1. This is not the website. Is that website? Yeah, I'll show this website instead. Okay, so you can see it's 10 to the power, it's 10 to the power 18. Then I guess Kway is 10 to the power 15. Then 10 to the power 12 is Mway. Then 10 to the power 9 is Gway. Then we have Sesbo. Then we have Finney. Okay, so this is what the Ethereum conversion rates are. All right. Transactions on the Ethereum network involve sending Ether or interacting with smart contracts. Each transaction requires computational resources, which are paid for using a unit called gas. Okay, a gas, measure of the. Okay, we'll see this thing when we'll start with solidity. Okay, it's not important right now. Okay, now let's talk about types of transactions. Sorry, not types of transaction, types of blockchain. So right now there are 3, but all the 3 are classified into 2 only. Okay, first is known as permissionless blockchain or public blockchain. Permissionless blockchain or public blockchain. Take the example of Bitcoin, Ethereum, Solana, Algorand, or any other cryptocurrency. You don't require any command or you don't require any permission to join the network. Everybody is allowed to join the network. So it's a public blockchain, publicly available to everyone. Okay, so let's read it. A permission blockchain is a type of blockchain where anyone can join the network, participate in the consensus process, and read or write the transactions. Okay, these blockchains are open to the public and do not require any permission from central authority. All right, they are also known as public blockchains. Bitcoin and Ethereum are the most well-known examples of permission blockchain. Anyone can participate in mining, everyone can do it. Yeah, the only thing is you must be having a supercomputer. For Bitcoin, all validating transactions and all transaction history is publicly accessible. I have showed you this. Okay, we can access everything. Example I have taken, imagine a giant library where anyone can enter, read any book, or even add new books to the collection without asking for permission. Everyone can see what books are there and who has borrowed them. Everything is transparent and public. Now, another form is known as private blockchain. There's another name for it as consortium blockchain or permission blockchain. Okay, it's a private blockchain. It's a private blockchain. That means if you want to join it, you must be approved by the authority first. Let's take the example of XLR. Let's suppose I created, not I, the the management created a blockchain for XLR network. That means now only the XLR, uh, only the people who works for XLR, let's say employee, then we have employer, let's say even the students, okay, they are the ones who can access it. Suppose a person who doesn't belong to XLR, if that person tried to join the network, they will decline it. They will decline it. Okay, so private blockchain is not totally decentralized, as you can see, because here we need permission to join. We need permission to join. Okay, example is Hyperledger Fabric. Hyperledger Fabric is a private blockchain. Even our Indian CBDC e-rupee is made on this only. Now you must be thinking, sir, CBDC is public. It's public. Every Indian can use it, right? So how it's a private blockchain? But if you see from the world's perspective, so India is a private thing, right? Indian can only use it. Sorry, Indian can only use e-rupee. So it's a private thing. Okay. But yeah, if you look from the India's perspective, so it's public thing. Every Indian can use it. Okay. But from if you look from a world's perspective, so it's a private thing. So CBDC technology is totally based on Hyperledger in India. Okay. Now let's read it. A permission blockchain, on the other hand, is a type of blockchain where the participants need approval to join the network. These blockchains are typically used by organizations that require more control over who can access the network and who can read or write the transactions. Okay. Now, when I was working with Geo as an intern, I was hired as a blockchain consent manager intern. Okay, so they created an application. They were working on an application where users consent. Okay, users consent 100% ownership or 100% consent. Again, the word consent is with the users only. Okay, but only for the users who belongs to Geo network. All right. So this was their plan. Hyperledger Fabric is an example of permission blockchain. It is used by businesses and organizations that need to maintain privacy and control over their blockchain network. They don't want everyone to join. Okay, selected people only. Think of a private club where only members who have been approved by the club's board can enter. Inside the club, only members can participate in activities and some information is only shared among members. Suppose in XLR also, so when we created a XLR blockchain, okay, what management want to share only with the employer, okay, will be accessible to employer only, not to students, not to any employee. Okay. So again, some access control is maintained in private blockchain. All right. So yeah, we are completed with this topic also, the types of blockchains. Okay. Now let me just see some doubts. Tejaswini, tomorrow, yesterday was a holiday, Ganesh Chaturthi, and happy Ganesh Chaturthi to everyone. Yes, then it's a contract. Hello World, we created a small contract. Okay, and this remix ID provides it creates a local blockchain. So this information of Hello World, not the but the transaction. Okay, it's stored on blockchain, and it has address which is, yes, exactly. I told you, like every company has a separate identity. Similarly, every contract has a separate identity. Hi, Vinod sir. Arnav, this PDF is available on LMS. You can get it from there. Vinod sir, I think I discussed what Ton is the Telegram open network. So see, suppose I am a company that already had a different business. Okay, had a different business, but let's say I want to transition myself into blockchain. I want to do a fundraising so that people can contribute to my project, and those fundraise amount I can use it for the welfare of my company. So this is what Telegram did. Telegram, we all know it's a chatting platform. It's a social media platform. Okay. Uh, Dr. Vinod sir, I don't know about Jumbo. I have to see it. I have heard about its name. Ton, I think we all are aware that Telegram is one of the secure platform we have seen. Okay, when I was into digital forensic, okay, when I tried to decrypt or when I tried to perform forensic on WhatsApp in both Android and iOS, and I was also shocked that Android security is really poor. When I talk about WhatsApp, it was really easy to break, but yeah, iOS was really strong. Yes, Nilesh, Poet. Okay, okay, and I'll explain Poet again. Okay, so Jumbo, I have to see it, sir. Tomorrow I'll update. I'll also learn about this Jumbo. I have heard about this chain, Jumbo chain. Okay, Telegram, they shifted their working to blockchain. Why? Because I guess there were multiple reasons. They want to be decentralized. Okay, so that they can be safe from all the compliances. I guess one there was a time the CEO of when the CEO of Telegram, I think uh, he got jailed for some reason. I guess he was denied to share Telegram's data to the government. So I guess that's the reason. Ton has metaverse environment or too. Okay, I'll look at that, sir. Okay, but Telegram, it's really safe. Telegram, it's really safe. It's really safe. Okay, and they did their ICO as well. If you guys know, they did their ICO so that people can contribute to their project. Okay, and they use those fundraise for their welfare. What is a channel? A subnet of our private data. Yeah, Yamuna, you can say it's a channel. It's a network segmentation part where we create a subnet for private data. Exactly. Right. See, Nilesh, I think Poet, it's the proof of elapsed time which we discussed. Right. Now, if you remember, suppose there are four people. Okay. Now just imagine all four peoples are blindfolded. Okay. Now they open their mobile and they randomly assign a timer. Okay. Now the first timer that goes off first, okay, that person will be selected as a winner to create the block. Okay. Now, if I think yeah, now let's come to Hyperledger Fabric. So Hyperledger Fabric, sorry, not Hyperledger Fabric. Hyperledger Sawtooth uses Poet, proof of elapsed time. Okay. So for that, if you are a member of Hyperledger Sawtooth, they will be giving you a hardware which you have to connect with your computer, with your laptop, and that hardware will provide the random timer. Okay, so that's what Poet is. Everybody get chance on the basis of the timer, on their timer, who on the timer who goes off first. Okay, who goes off first. Okay, how does the execute order commit model work? Oh, Yamna, sorry, I'm not aware of that. I'll check it. Execute order commit model work. I have to see this thing. Jim, I'm not aware of that. Okay, I'll see. I'll see if it's related to blockchain. I'll see it. Okay. Execute order commit model work. Sorry, I'm not aware of that, Yamna. I'll see and let you know tomorrow. Okay. I'll just copy this question. Yes, and it's complicated. Okay, it's really complicated. You have to buy their hardware. But it's the most neutral form of neutral form of consensus mechanism that I have seen right now. But for SBI e-rupee, how does it work? Sorry, Nish, I'm not getting you. It's for everyone. See, initially all the bank refused to use CBDC. They said no, we want to control the data. But RBI said no, it's mandatory now. Okay, it's mandatory. So now all the banks, okay, that are holding everyone now, SBI, HDFC, even with Union Bank of India. Okay. Okay. Anab, I guess Excella management will help you with that. Okay. No, Nilesh. We don't have to buy it. See, we are just the users. We are just the users. Everything is done by RBI. RBI controls everything here. I know it's not up and the concept of blockchain, but they are using blockchain, but they are applying a bit of centralization. So you don't have to buy anything. We don't have to buy anything. And I all told you that Hyperledger Fabric and Hyperledger Sawtooth are different. Hyperledger Sawtooth uses a poet. Okay, Hyperledger Fabric, I'm not recalling what they use. Okay, so they just created an application. Our users are just transferring it. Okay, it's like I'm transferring you Bitcoin. So for if I'm transferring you Bitcoin, I don't have to go through proof of work, right? It's the one who provides security to the network. Okay, who runs the blockchain? We are not running the blockchain. We are not running Bitcoin. We are just using Bitcoin to transfer each other. Okay. RBI is mining it. RBI is mining it. Okay. All right. RBI is actually the thing is not RBI is mining it. Suppose I want a 10 rupee e note. So I will mine it. Okay. I will mint it. I'll not mine it, I'll mint it. Okay. So it will create it for me. I mean, the RBI will create it for me. Okay. Okay. For our lecture, I'll take the CBDC concept and we'll learn everything from scratch. There's a very good website paid by PwC. So they have mentioned on how exactly this CBDC works. Okay. So we'll see that. All right. Tomorrow we'll see that. How many peers in a network needs to endorse a transaction? See, Yamna, when I talk about Bitcoin, so it's really large. It's really I'm not aware of the number, but I told you that like there are right now 21,000 nodes inside block in Bitcoin. Okay. But what matters is, Yamna, that the network should be totally anonymous to each other, totally decentralized. Okay, there should not be grouping or clustering. Okay, sir, how will CBDC be mined? For that, you guys have to install your bank's application into your mobile. Okay. Then I think let me just think of it. Mhm. No, Pavan, UPI and CBDC are not same. Why they are not same? Because when we talk about UPI, so UPI is a payment system. It's a payment system. It's a payment facilitator. Okay. But when we talk about CBDC, CBDC is the Indian rupee. CBDC is just a representation of your physical e-money. Sorry, of your physical cash. Okay. So it's different. UPI is a payment facilitator. It's a payment. What did I said earlier? It's a payment facilitator. It's a payment system. On the other hand, CBDC is the Indian money. It's the Indian rupee. Okay, in the electronic form. Yes, sir, we can do it. We can convert our existing cash funds in bank to e-rupee. Yes, sir, we can do it. I think let's install our natives bank application for CBDC. Okay, so then you guys can able to understand it. Okay. I'll take another session for just CBDC. Okay. Yes, Mohammed. CBDC is a centralized network. Why? Because RBI controls it. In India, RBI controls it. It's not totally it's not decentralized. It's not like there are multiple users that are, that holds the data. Here only RBI holds the data. The ledger is maintained by RBI. And if you are doing a transaction less than 50,000, okay, it is not stored by anyone. It is not stored by anyone. This is what RBI is saying. RBI said we are also not storing it if the transaction is less than 50,000. I don't know what's the truth here, but this is what they're saying. And they also promised, not promised, but they said your bank will not be holding any information of this. If you are sending 1 lakh transaction to anyone using CBDC, your bank will not hold this information. Okay, your bank will not hold this information. All right. So I'll take a separate session tomorrow. We'll start with CBDC. So I'll clear everything which is related to CBDC tomorrow. Okay. It's really interesting. There's a very interesting topic in CBDC which is known as programmability. This is it's good. It's bad, not bad, but yeah. Again, pros and cons. Okay. Nilesh, what bank do you use? What bank do you use? SDFC. So I'll show you. Wait. So if you just Google it, SDFC e-rupee app. So this is the one you will find it on the App Store. SDFC Bank Digital Rupee app or Digital Rupee by SDFC. So you'll find this application. For every bank, now it's available. For Union Bank of India, it's by e-rupee by Union Bank of India. For ICICI, it could be a different name. Let's check for ICICI. ICICI e-rupee app. So it's by the name digital currency. No, it's not by the name digital currency. It's by the name digital rupee by ICICI Bank. Okay, just install it. Try to work on it. Suppose if you have 500 rupees in your bank, now try to convert them into the tokens. Okay. People are crying for that app. Why they are crying, Nilesh? I'm not getting you. It's not available. SDFC e-rupee app is not available. Oh, let me just check. It's available. See, if you guys can see my screen. HDFC Bank Digital Rupee. This is, I think, yeah, this is the name. This is the name. If you guys can see the blue logo. Okay, it's for everyone. If I check for ICICI Digital Rupee by ICICI, yeah, this is the one. This is the one for ICICI. Okay. No, Mohammed. I don't think so. See, both are different technology. UPI is different and CBDC is different. What important is that they should work together. And I think government is working on it. Now both are interoperable with each other. See, there's a term which is known as financial inclusion. You know what financial inclusion is? Anyone? Financial inclusion word. It's a very important word from the in the finance space. What do you mean by financial inclusion? Anyone? Financial inclusion? Anyone? See, financial inclusion means that everybody inside the country whom doesn't matter who they are or where they live should be accessible with all the financial services that are available in a country. It should not be like the rich can only use it or the poor cannot use it. So it's not like that. India have to maintain financial sector so neutral so that everyone can use it. This is known as financial inclusion. Yes, Vinod sir, financial is the goal of providing affordable and appropriate financial services to everyone, no matter who you are. Okay, so that's really, really important. So if you guys remember when UPI came, everybody questioned that, oh, how the poor people, the small vendors can use or you know how they can use this UPI. Okay, you should be digitally sound to use that. Now you can see everybody is using UPI. So UPI is the one who increase financial inclusivity in India. Okay. So now suppose if a guy is using UPI and another guy is using CBDC, and if they want to do a payment, suppose I'm using CBDC and let's say Dr. Vinod sir is using UPI. I said, Dr. Vinod sir, can I send you CBDC using CBDC? Dr. Vinod will say, no sir, I don't accept CBDC. I only accept UPI. So it's a barrier. It's a barrier. So this barrier shouldn't be there if you want India to be more financial inclusive. Okay. I think you will see on Google as well. Just Google it. What is the Indian rank? I mean, what is financial inclusion rank of India? Just check it. I think it's above 60 right now. Okay, that means still there are people, there are sector in India where financial services are not provided with with that efficiency. Okay, so right now again I was on that example that suppose Vinod sir is using UPI and I'm using CBDC. Now how do I do the payment? So this is known as a barrier in financial inclusion. So what RBI has did, RBI with the help of NPCI, they have made in CBDC and UPI interoperable with each other. That means if I'm using CBDC and if the other person is using UPI, I can still do the transaction. My CBDC will be converted to UPI and yeah, the recipient will receive it. So this is known as interoperability. Now it's done. I mean, it started. You can easily convert it. So the question again, can UPI, sorry, can CBDC replace UPI? So the answer is no, because both are different technologies. UPI, like I said, it's a payment facilitator. It's a payment facilitator. Suppose if I'm giving someone 500 rupee note using my hand, so my hand is a payment facilitator. Okay, my hand is doing the payment. Similarly, UPI is the digital hand who is doing this transaction. But CBDC is the Indian money. It's the Indian rupee. A 500 rupee in my hand. If you convert it into its digital form, that's CBDC. So CBDC is not a payment facilitator. It's the Indian rupee. I guess you guys getting what I'm trying to say. CBDC is the Indian money. It's the Indian rupee. It's the legal tender. It's just another form of Indian rupee. But on the other hand, UPI is just a payment facilitator. Okay. Yes, they are also getting NFC near field communication. Exactly. Without the need of internet, you can do CBDC. Okay. Exactly, Vinod. So thank you for mentioning that. Exactly, Mohammed. CBDC is just a digital form of Indian rupee. UPI is a payment facilitator. There's a difference between them. I hope you guys are getting what I'm trying to say. Okay. Please send the link of SDFC. Okay. How do I send the link? Okay. Let me just check. SDFC e-rupee. Oh, this is, try to do it by yourself once. Okay. Then you will be having more clarity. All right. Yeah, see, right now CBDC is still in its initial phases. So it's upon the user. If user started to use it, okay, they will improve it by time. Yes, Karthik, they have, Dubai is using CBDC. Japan currency, which is yen, they are using CBDC. Now the thing is, if India CBDC is linked to another country CBDC, the cross-border transaction can be made really, really efficient. Suppose if I'm living in India and my friend is living in Japan, okay, doing a normal transaction, I don't know how to do it. But with the help of CBDC, what will happen is my Indian e-rupee will be converted to e-yen. A yen is their currency, and you can directly send it to your friend who is living in Japan. So now government are trying to facilitate a communication between all the CBDCs of other countries as well. America declined. I mean, Trump declined that they will now never be using this CBDC. I don't know what's the reason. They said we want a decentralized money. Okay. So this is what they said. But again, the thing is, see, by using CBDC, your data will be in the your data is in the direct hand of RBI now. Okay. So yeah, that's again something which is, I guess, let's say, what I believe is a drawback. Okay, if they remove physical money totally, okay, so it's not a good thing. It's not a good thing. Okay, because now what are you doing with your money? Everything will be recorded with RBI. So that's also not a good thing. Okay. Nilesh, is this happened to you, or is this a comment from anyone else? Is this a comment by anyone else? Okay, try to do it by yourself also. Okay, I think by this you will be having more clarity. Oh, two two rating. Okay. Hmm. I will wait. All right, all right. Even I'll try. I haven't tried it yet. I'll also try it. Okay, let's take a 10-minute break. Okay, and then we'll meet around, yeah, at 8:32. Okay. Okay, I'll take a questions. Pawan's asked, convenience fee are applicable in CBDC. Right now they have said no. Right now they have said no, that there will be no convenience fee. Okay, I don't know about the future, but right now it's the convenience fee is not there. Okay. Hello everyone. Shall we start now? Hello, am I audible?
Yeah, yes, sir, you're audible.
Okay. Just do this. I'll start then. All right. Now let's see some use cases. Okay. Now today we'll be discussing on how blockchain is useful in the healthcare field, how it is impacting the healthcare field. Okay. All right, I'll share my screen. I think my screen is visible. My screen is visible, right? Just let me know. Okay. All right. Again, Algorand, one of my not my one of my it's my favorite blockchain because it is solving problems, okay, from on a ground level. In the previous session, we had seen how they are helping Assam tribal community, okay, because they had a heritage from a long time. They are creating their own hand woven cloth, which is known as gamosa. Okay. Similarly, now they are utilizing themselves into the field of medical research. Okay. So let's check. So the project name is LabTrace. It's used for protecting the integrity of medical research data. Okay. Again, I have taken an example. Okay. Let's see this example. Imagine Dr. Aisha, a young researcher studying Alzheimer. Okay. Now, under the traditional system, she records trial data in laptop and shares result in Word or PDF file. Okay. Months later, another group publishes similar results with and claims priority. Okay, what happened was a month later, another group publishes similar results and claims priority. Aisha, Dr. Aisha has no way to prove she was the first to generate the data. Okay, she has no way to prove herself that the data she generated was the first. Okay, was the first reference. Okay, now with the lab trace on Algorand, every data set Aisha creates is instantly given a CID and timestamp on chain. CID is again a unique what do I say, a unique, like a hash. It's like a hash. Okay, it's a unique ID given to the Aisha's data. Okay, and everything will be stored on blockchain. Everything will be timestamped. Now, what will happen? The ownership of her research is cryptographically proven. Okay, if she applies for a patent, she can present blockchain verified data as evidence of originality. If you are into patents, I was into patent before, so I know how difficult it is to prove, is to give evidence of your research, of your original idea, not idea, of your original invention. Okay, so blockchain verified data can be presented as a evidence of originality. Now, if she shares MRI scans with collaborators, smart contract ensure only authorized people can access them, preserving patient privacy. Patient privacy is really, really important, guys, because with a patient, regarding the patient's privacy, a sensitive information is always associated. It could be DNA. What do I call it? I'm not a bio student, but there's something. But yeah, related to DNA. So your DNA information is a very sensitive information. Okay, you cannot give it to anyone else. Okay, so now with this, if she shares a MRI scan with collaborators, suppose it could be any high medical organization. Let's say in India we have, what's the name, Apollo we have. Okay, smart contract ensures that only authorized people can access them, preserving the patient privacy. Now, with the left trace project, Aisha is protected against plagiarism. Nobody can copy it, her data. Her lab's credibility rises with verified data integrity. Regulatory approval processes like drug trials move faster with transparent and tamper-proof record. So it's really good. Now let's understand again the problem with the conventional research data. Okay, so in today's digital world, especially with the rise of AI, artificial intelligence, scientific research faces a crisis of trust, and I think we all feel it. Okay, manipulated or fake data. Thousands of scientific papers are retracted each year because of falsified or unreliable data. AI tools can now generate fake results, making detection even harder. Okay, lack of provenance. What is provenance? Provenance means the history, the origin. So traditional systems do not reliably capture who created the data. It's all the time fragmented. Okay, I think I have mentioned I have done my law as well. So it was really difficult for me to find a original paper and to read it. Okay, when it was created or how it has changed over time. It's really, really difficult. Weak protection of intellectual property, your patents right. Let me just hide it. Researchers often struggle to prove ownership of their discoveries, making them vulnerable to data theft and plagiarism. So these are the problems. Another problem is slow and costly verification. Why? How? For drug trials, patients, or clinical studies, verification of data is time consuming. It is most of the time expensive as well and prone to disputes. Impact on human lives. Inaccurate client trial data can delay life-saving drug approvals, okay, or lead to unsafe medical recommendations. All right. Now, how blockchain, the project LabTrace solves this problem. So LabTrace on Algorand blockchain provides tamper-proof verification of research data from the moment it is generated. Okay, so it provides a tamper-proof verification of research data. So how it's done? So there's a on-chain notarization. Notarization, you know what notarization is? Okay, it's the way to prove your document, which it's authenticated, it's really genuine. Okay, so every piece of data, a scan, an image, or a lab result is given a unique content ID. We'll discuss what unique content ID is. Just imagine it as a unique ID given it to everyone, given to every data, a digital fingerprint. Okay. Following IPFS standards, I'll explain what this IPFS is. Okay. The CID is stored on chain, proving its originality. Secure time stepping. Each data set is timestamped the moment it is created, ensuring authenticity and immutability. Provenance and authorship certification. Researchers can prove ownership of their discoveries, okay, their notes or their inventions, protecting their intellectual property. Smart contract access control. Using Algorand role-based access control, permissions can be granted securely. Suppose I am a patient, okay. Now, with the smart contract, I have this power to allow who can see my data and who is not allowed to see my data. I don't want everybody in the healthcare management should see my data. I only want that only my doctor and the medical guy should be able to see my data. So I have this power. I have this power. Okay, I have my consent to provide the data. Okay, auditable and transparent record. creates a verifiable trail of how data was generated and used, which strengthens regulatory approvals and compliance. Okay. Now, real world adoption. Let's see who has adopted this project. So, Bill and Melinda Gates Foundation, by the name, I think their project is by the name, yeah, the Unity project. So they are using this lab trace to authenticate infant brain scans from portable MRI devices in low resource setting. Blockchain ensures scans are authentic, preventing manipulation and building trust in global health research. Okay. Next project is Integrity Lab or open source notebook, a blockchain-based alternative to traditional lab books, enabling students, professors, and researchers to record research notes, data, and code in a transparent and verifiable way. Now, I know who is not into biofield, it's really difficult. Even I'm finding it difficult to understand everything. Improving on GitHub, Overleaf, and similar tools. What I got from here is that everything is transparent as well as everything is private as well. Okay, transparency that many organizations, I mean there are various independent bodies, okay, who runs this blockchain, I mean this lab trace. Okay, now again, if I'm a patient, I only want this doctor to see my data. So again, ownership, the consent is with me right now. Okay, also they have told that with the advancement of AI, fake data are being created, which is really not good in the health field. Okay, because anyone can fake the trials are really important in health field. Okay, so if someone has faked the trials, okay, so it's really not good, it's really concerning. So blockchain can solve this problem. Only authenticate data, its provenance from its origin to the person who is seeing it. Okay, everything is stored on blockchain. All right. Now, next project is Yale University Blockchain for Genomic Data Security. This is for DNA. You know, DNA is again, I'll tell, it's a sensitive information. See, we have the data scattered into two ways, a personal data and a sensitive data. Personal data you could share, but sensitive data it's really sensitive. You cannot share. All right. Okay, now let's check. Imagine you do a DNA test to learn about your health and ancestry. You know, if you do a DNA test, you could find out that if there's any disease, or if there's any disease associated with your health. Okay, so DNA test, I think it's really expensive as well. Okay, so you do a DNA test to learn about your health and ancestry. You can see about your ancestors, okay, and their health. Everything is coded inside the DNA. Normally, the company that does this, they store your full genetic data in their servers, and you do not control it. Okay, your genetic data is stored in their servers, and the important thing, you are not even have a control on it. Okay, now with this product, with the same chain, your genetic information isn't fully stored. Only the important differences from a standard reference genomes are kept. So what this blockchain is doing is, they're not storing your entire genome data, but it's really large as well. Okay, it's really, really large. So what they're doing is, they are taking a normal DNA, normal reference genome, and they're comparing with your genome. Only the differences, only the thing which is of important, or is of a sign of warning that this is something which is really the patient has to consider about in the future. So that information, the critical information, okay, which got from the reference of taking a standard reference genome, okay, is stored on the blockchain. So this is small and it's easier to manage. Okay, I was reading this project. So if you do a DNA test, okay, so the data is really, really large, guys. It's really, really large. So now, right now on blockchain, they are not storing the entire data, but there's the important differences. Okay, when they compare with the standard genome. Okay, example, you want to share part of your genetic data with a doctor to check if you are at risk of a certain disease or not. Okay, you want to share share part of your genetic data with a doctor to check if you are at risk of a certain disease or not. Instead of handling over your entire DNA file to a big company, SAM chain lets you securely give your doctor access only to that relevant part of information or relevant piece of information, not the entire information. So you still you are still the owner of your DNA data, which will not see in the conventional system. Okay. Now problem with the conventional system, access barrier. Oh shit, this is the old data. Oh my God. I forgot to, yeah, I think this is the one. Yeah. Private blockchain network. How SAM works. Operates on a permission blockchain. So they are using a private blockchain because they don't want anyone to participate, right? They only want only the known authorities. Okay. The doctors should able to access it. Efficient storage. Instead of storing the entire genome, which is a huge data, it records only the differences between an individual genome and a reference genome. Okay, scalable approach significantly reduces storage needs while ensuring access. So this is their, I guess, the research paper. Okay, once you'll receive this document, you guys can see it. Okay, now the use case 7, MedRec. I think my battery is a bit low. Just give me 2 minutes, guys. I'm just coming. Oh, I just saw the messages. Was my PPT not visible? Oh shit. Okay. Let me just check. My internet is working properly. Okay, let me just share it again. Then let me know. Oh, okay. Okay, let me just check again. I'll share the entire screen now. Now let me know. Is it visible? Is it visible? Is it moving? How do I get to know? Not able to see you guys. Is it visible now? Okay. All right. Okay, the last use case is decentralized medical data access with blockchain. MedRec. Let's take an example. Meet Raj, a patient with a chronic condition who visits multiple clinic. Okay, who visits multiple clinic. Old system. Each clinic stores Raj records individually. Okay, when he moves or sees a new provider, they struggle to access his history. I think we all have faced this problem. Raj has no easy way to control or track who accesses data. Okay, so that was the problem. Not in India, but I guess in abroad there are related problems like this. Okay, with Metric, Raj access log is stored on the blockchain. Whenever Raj visits a new provider, that provider gains access through blockchain control system. Okay, Raj can see in real time who has viewed his records and has the power to grant or revoke the permission. Okay, so ownership, the consent is with him. Meanwhile, now I told you blockchain is a decentralized network, so there will be people, okay, that will validate all the things. So here, public health researchers act as a miner. They act as a miner here. Okay, so public health researchers acting as miners help secure the system. In exchange, they obtain anonymous insights into health trends, valuable for disease prevention and policy making. Okay, so it's really good for them. It's like a relation. Okay, they protect the network. Okay, they help secure the system, and in return, they get a idea, they get insights. Okay, about what's happening. All right, into health trends, valuable for disease prevention and policy making. Now, the problem with the conventional medical record systems. Fragmented records, as I discussed earlier, patients' health data is spread across disparate providers. It's with everyone. When moving between hospitals or clinics, it's hard to access past records. Second, limited patient control. Providers, not patients, I'm not talking about patient, providers, healthcare providers, typically control medical records. Okay, patients face hurdles and delays. Now, there's a law. I'm not able to recall the full form of it. It's a HIPAA Act. Okay, it also says that up to 60 days of up to 60 days. I mean, the providers are given with 60 days. If users wants to get their data back, so you can see 60 days. 60 days also. Oh, up, up, what do I say? A long time. Okay, instead, every patient should able to access their data instantly. Okay, inefficient data sharing. EHR systems from different institutions often can't communicate, making interoperability a significant challenge. Lack of incentives. Institutions have few motivations to share data, and health information blocking remains a problem. Lack of incentive. Institutions have few motivations to share data, right? While they will share the data, if they're not getting anything in return, okay? Because again, lack of incentive. Right. So health information blocking. They block the information. They don't share the information with each other. So that remains a problem. But with the blockchain, they are providing incentive as well. All right. So how blockchain or Madrake solve this problem? Immutable decentralized access logs. Madrake uses blockchain to maintain a transparent, unchangeable log of access to medical data, giving patients ownership and visibility across providers. Modular and interoperable design. It integrates with existing local storage systems. Yeah, this is very important, guys. Okay, if I'm a provider, okay, if I'm a provider, let's say the patient's laptop. So you don't have to create a centralized repository or anything before. Even your local storage systems is now interoperable with the Matrix. So they directly take their data from your laptop or the provider's laptop, and yeah, with the blockchain they log into the ledger. Okay. So this is what they're saying. It integrates with existing local storage systems, avoiding the need for a centralized repository. Incentivize participation. Like I told you, the researchers who act as a miners. Okay. So researchers, public health authorities, and other can act as a blockchain miners. As rewards, they receive access to aggregated anonymized data, creating a data economy. Okay, they'll be getting trends about the health related issues and everything. Enhance confidentiality and accountability. Blockchain properties ensure secure tracking of who access records and when they access the records, enhancing confidentiality and auditability. So yeah, that's the one. One more project, I was reading it today, and it's, where did my touchpad? Not able to see my mouse. What happened? Okay. So there's a project by the name Chronicle. I'll write the name here. I want you guys to read about it. So they are actually, it's a nice project. I guess ma'am is calling me or something. Okay, I'll just take 2 minutes more. Yeah, so this is this project Chronicle. I want you to read about it and we'll discuss it tomorrow as well. It's a very good project. It's used for drug traceability. I'll write the reason. Drug traceability. Okay, it's used for drug traceability. All right, so I want you to guys read about it. Okay. Feedback link. I don't have feedback link. Can anybody provide feedback link to Sujata, ma'am? Any doubt, guys? Any doubt? Attendance link is provided above. Let me just attach it again. Okay, it's available here. Wait. I'll paste it again. So this is the one. Okay. Any doubt, guys? Tomorrow we'll be learning about CBDC. It's really interesting. Okay, we'll see how exactly RBI is implementing the system across India. What are the other CBDC models adopted by other countries as well, which this is also we'll see. Okay. But please look at this project, Chronicle Web Project. Okay. And also try to find out how Indian government is working on drug traceability system using blockchain. I'll write it here. Okay. Yeah, I've written it here. Indian government on drug traceability system using blockchain. And this project, I'll mention the name again, Chronicled. Try to find out what they are doing. Okay, it's a good project. They're using a concept known as crypto seal. I'll also write it crypto seal. Also look what this concept is, crypto seal. Okay, very interesting thing. Dr. Vinod sir, you mentioned NFC. So this crypto seal works on this NFC concept. Okay, so I wanted to look at this and how this Chronicled is using crypto seal, which is just the NFC concept. All right. Okay, and we'll discuss it tomorrow as well. Any doubt? Okay, I guess we don't have doubts now. All right, let's meet tomorrow. Good night, guys. Good night, everyone.